Hi, welcome to Chem 6161. Today we will talk about the Diels Alder with Evans auxiliaries. Okay, this is the reaction that we will study. Basically, we will use this diene that we have been using during all of our lectures, and we will use this dienophile. As usual, this diene is electron rich, the dienophile is electron poor, and if we do the regiochemistry, we know that this is density negative charge, density positive, density negative, density positive, and this obviously has to be density positive, density negative. That means that what is happening is that the reaction is this. An important thing about the Evans auxiliary when we are doing the Diels Alder is that in the major part of the cases we are using a metal to activate the reaction. Okay. When we are using a metal, the first thing that is happening is that we are forming this chelate. Yeah, that means we are fixing the conformation of the dienophile in this way. Another important thing is that we have two possibilities here. I draw the double bond in this direction, but also I can draw it in this direction. Isn't it? In this case, we will apply the same theory that we use it when we are doing anodides. When we put the alkene in this position, it's crashing with the substituent of the oxazolidinone. That means that this destabilizes this conformation, and what we have is this conformation. Okay? This will be the conformation that we will use to do this reaction. Then we put the diene as usual, perpendicular to the slide, okay? And then I do the approach for both sides of the diene. That means I can do it like this. I only draw a cycle in order to try to keep some space. And if I do this, okay, sorry. This is the double bond, and then what is happening is that what we have okay, I have to put the diene in this direction, remember? And the carbonyl group inside, because remember that the Diels Alder is always endo. That means I will draw here the bisoxazoline, okay, and I put the chirality. Okay? This bisoxazoline is blocking the lower phase. Yeah? The only that I did is to turn 180 degrees this. That means if this double bond is coming from the top side, the top face, what is happening is that this phenyl will crash with the diene. If instead the dienophile is coming from the bottom face, this phenyl is going more bottom, that means that will not affect. In the first case, because we have a crashing with the phenyl and the dienophile, this will be disfavored. That means that this double bond has to come from behind. One we know which is the phase where the double bond is approaching, we do the reaction. That means this will give, okay, the six-member ring. I put the methoxide. Okay, and then if we are forming this bond, this methyl will go down if we are forming this bond, okay, the bisoxazoline will go down. Okay? And this will be the final configuration of the product. Okay? This is how it's working, the Diels Alder with 7th auxiliary. If we are doing the opposite exercise or the opposite question, that means we have the final component, we have to determine which auxiliary we need to use, which chirality of the auxiliary we need to use. What we will do, the easier way, is by trial and error. Okay, I imagine that they told us that we will have to get this combo. Okay, and anti-pure. These can come from, here we have an ester. What we can do is, instead of the ester, we can put the oxazoline. Okay, which chirality I put? I have to choose one. I will choose, for example, this. Okay, and we will see if it's a correct or not. Then, if we follow the retrosynthesis, this is coming from okay. Okay? And then I do this reaction. That means I have here the diene perpendicular to the plane of the slide, and then I add this, the alkene. In this case, the alkene, the phenyl is facing up. Okay, that when if this alkene is coming from the bottom face, this phenyl will crash with the dienophile, destabilizing the transition state. It means that the product will be with this alkene on the top. Okay? And we are forming these two bonds. If I'm forming this bond, I draw a final structure. If we are forming this bond, what we will get is this methyl up. Okay? If we are forming this bond from the bottom, from the bottom face of the alkene, what we will have is the oxazolidine up. Okay, and then what I do is to compare this compound with the starting material, with the final compound that I need to do. In this case, it's the same stereochemistry. That means that I put the right chiral auxiliary. If I get the opposite enantiomer, the only that I need to do is to change this chiral center, okay, and putting the opposite enantiomer in the chiral auxiliary. And that's all. Okay? Remember, the most important is that we have the metal that is coordinating these two. In this case, we don't have to minimize the dipolar moment, okay? Then, as in the case of the enolate, the the double bond has to be cis to the oxygen, and then we only need to do the approach. Each phase approach, and determine which will be the chiral centers. Okay? Thank you very much for your attention, and see you in the next lecture.